Thank you, Bob. Good morning, everyone. I'm looking forward to the sound effects that I might have during my talk. Before I begin, I just wanted to acknowledge my co-authors on this paper, fellow colleagues at the Gabrumpa, Julia Chandler, Melissa Cowlishaw, Kirsten Dobbs, and Fergus Malloy. I'm going to talk about three things this morning, a little bit about the outlook for the Great Barrier Reef and the Outlook report that we released last year, and then how that flows into a new assessment of our scientific information needs for management of the Great Barrier Reef Marine Park. And then right at the end, I'm just going to talk about something a bit different, which is a new online integrated information and application system for permits for working in the marine park, including permits for researchers. So I'm sure most of you who work in the Great Barrier Reef are aware of the Outlook report and hopefully have had a look at it. We released it in September 2009. The Great Barrier Reef Marine Park Act now actually requires the Gabrumpa to produce one of these Outlook reports every 5 years, and the next one is due in 2014. The report is broken down into 8 different assessments, and I'm not going to go through every one individually, but suffice to say that there are a group of 3 that are based around the values of the Great Barrier Reef, 4 that are based around pressures and current responses to those pressures on the reef, and then the last is the future outlook for the Great Barrier Reef. So this report is really part traditional state of the environment report, including a condition pressure response approach. It's part risk assessment, part assessment of management effectiveness, and then finally that future look to the outlook for the ecosystem. And as a mark that this is quite a successful approach, the committee that is in charge of producing the next national state of the environment report has decided to use the process and the framework that we used for the Outlook report as the model for the next national state of the environment report. So there is quite a bit of good news in the Outlook report. The Great Barrier Reef is one of the most diverse and remarkable ecosystems in the world. It's one of the healthiest coral reef and tropical marine ecosystems, and if we do say so ourselves, it's a leading example of world's best practice management. The Outlook report is heavily based on science for the reef, and in particular a lot of the science of the centre, and many of the people in this room have conducted the science on which the Outlook report is based. This is just one example of the work of Gary Russ and his colleagues looking at coral trout densities in blue and green zones. But of course the Outlook report is not just about the coral reef components of the Great Barrier Reef, it's very much about the whole ecosystem, and I've picked just one example of that. This is monitoring of the humpback whale population and its very significant recovery since whaling was banned in the 1960s. Of course, also the Outlook report is not just about the biophysical ecosystem, it's very much about the social, economic and cultural aspects of the marine park. So we have information about the economics of industries in the marine park, information about the tourism industry in the marine park, information about recreational use of the marine park, and these are all critical components of the Outlook report and critical components in general of the scientific underpinning for reef management. Social and economic sciences are just as important as natural sciences. So that was mostly a summary of the good news out of the Outlook report. Not surprisingly, it's not all good news. And I just wanted to dwell for a moment on the risk assessment that we did. Now, I'd like to stress that this risk assessment is taking into account the existing management initiatives to control these risks. So this, if you like, is an assessment of residual risk given existing efforts. So it's a very traditional approach. Across the top, we have a range of likelihoods of different risks. Down the right-hand side, a range of different consequences, and we assess each potential risk against those 2 criteria. Now, I'm sure you're glad I'm not going to go through every single one of those, but I'd just like to focus on the top right-hand corner, which obviously is where the very high and high risks are. So we have a series of risks that are associated with climate change, a series of risks associated with declining water quality from catchment runoff, impacts from fishing, particularly illegal fishing and poaching, and coastal development. And these are the remaining sources of significant risk to the future of the Great Barrier Reef. I think it's worth just taking a moment to actually read the overall conclusion of the Outlook report. The outlook for the Great Barrier Reef ecosystem is at a crossroad, and it is decisions made in the next few years that are likely to determine its long-term future. Unavoidably, future predictions of climate change dominate most aspects of the Great Barrier Reef's outlook over the next few decades. The extent and persistence of the damage to the ecosystem will depend to a large degree on the amount of change in the world's climate and on the resilience of the Great Barrier Reef ecosystem in the immediate future. The bottom line, the overall assessment of the outlook for the Great Barrier Reef is that that outlook at this point in time is poor. Clearly, this is a great concern to the government. The Queensland and federal governments put out a joint response to the Outlook report, which was basically a commitment to a renewed focus and reinvigoration of existing efforts. There's no brand new ideas in this response, but there is a commitment to continue working to try and deal with those remaining risks to the reef. The one that I'd particularly like to draw your attention to is research to support management and protection. This is particularly important because not only is the Outlook report based heavily upon the results of science, but indeed Gabrumpa's entire adaptive management framework is also based on science. So just to give you an example of this, the Outlook report itself is available both as a hard copy book, but also as a web system. And on the website there is, I thought I'd had a checkup and I was okay, but maybe not. In order to document the science that we used for the Outlook report, we actually built an online system that has 600 individual pages, and each of those pages is a reference to a particular scientific paper or report. This is just one example of a paper by Malcolm McCulloch, and this is some of the work that he showed us yesterday, his flood plume work from the Burdekin. These web pages on the Gabrumpa site are not Gabrumpa's spin or interpretation of the science. They're just direct quotes from the papers. We're trying to lift out the graphs, figures, text that we think is most relevant to a particular reef management issue. And as you read the Outlook report and you see how the science is cited, you can then actually go to, in this case, excerpts of the research, but also links to PDFs where copyright laws allow us to, of the full paper. And we're trying to build this as an information system to help capture that corporate knowledge of the science underpinning for the management of the Great Barrier Reef. Having said that the Outlook report is heavily based on science, there is, of course, still, despite the Great Barrier Reef being a very well-studied tropical marine ecosystem, large areas of uncertainty. And this is just one example of an assessment in the Outlook report. This is for part of the ecosystem health assessment. The bit that I want to draw your attention to is all these question marks. So for all the various components of the ecosystem and the social and economic values and so on, we did make assessments of their condition, but we were very clear and transparent that for a lot of those, we were making those assessments on the best information we had, but not necessarily adequate information. There's still some pretty serious gaps in our understanding of the Great Barrier Reef from an adaptive management perspective. So recognising those gaps led us, after we finished the Outlook report, to undertake a separate exercise, which was to refresh our understanding of what are the scientific information needs for ongoing adaptive management of the marine park. We produced a separate document, which this is the cover of it. It's available in PDF form on the Gabrumpa website. And it tries to document what we know, what we need to know, and what ongoing monitoring we need to keep up with. Now, I'd like to stress this is available as a PDF on the website. There is also an interactive component to that website, which I'm going to demonstrate to you in a moment. But I just want to be clear that this is the Garumpa's attempt to better define the interface between science and natural resource management. It's an attempt to help you guys understand what we have as our needs for managing the marine park, but it's not the be-all and end-all. The Gabrumpa is very keen to collaborate with scientists to help scientific programs deliver into natural resource management, and in order for that we really need to partner with you guys. So please, I encourage you to explore this website that I'm about to demonstrate, but please come and talk to us if you think that your research is relevant to the management of the marine park. So this is the homepage of our Science Information Needs framework that we've developed. The first part of it identifies 5 overarching research questions that basically provide, if you like, the headlines for Gabrumpa's scientific information needs. Those of you who were involved in putting together expressions of interest for the National Environmental Research Programme will have seen these overarching questions as the guiding questions for those processes. Clearly, if you're trying to have 5 overarching questions for something as large and complex as the marine park, these are very broad questions, dare I say it, even perhaps vague, and there is more detail that I'll talk about in a minute. But I think those 5 questions actually are worth dwelling on just for a moment. So how can we best understand and manage the cumulative impacts of multiple pressures on the Great Barrier Reef ecosystem and the goods and services it provides? What are the effects of existing management strategies on the Great Barrier Reef ecosystem? Typo in this one. What adaptation strategies, including improvements to current management and completely novel strategies, could be used to improve the Great Barrier Reef's resilience, particularly in the face of climate change? How can catchment and nearshore management strategies in the reef catchment be improved to better protect coastal ecosystems adjacent and connected to the reef, and to improve water quality, ecosystem health, and ecosystem resilience? They would do that at the bit where I'm actually reading off the slide. And how can fisheries of the Great Barrier Reef and adjacent areas be best managed to maximise ecosystem health, ecosystem resilience, and ecosystem goods and services? So as I said, these are the headline questions. But there is a lot more detail on this web system, and that's what I'm going to talk about now. So this is the component of the web system that provides a framework for our scientific information needs. And for each of the issues that I'm about to talk about, we basically assess them against the degree of concern to management that we have for those issues, low, moderate, or high. And this is very much driven by our findings in the Outlook report, and also against adequacy of information, low, moderate, or good. And this is adequacy of information from the perspective of being able to manage the issue. Generally speaking, with some exceptions, if an issue is of low concern to management, it is not a top priority for us in terms of getting more science or information on that issue. The place where our focus is primarily focused is where we have a high degree of concern to management, but a low amount of information or low adequacy, and in particular where that low adequacy of information is actually hampering our ability to adaptively manage the issue to protect the reef. Let me describe to you how we use that. I'm not going to go through everything on this slide, but I want to draw some things out. These are the biodiversity components that were considered in the Outlook report on the left-hand side, and the threats and pressures to the reef across the top. The biodiversity components are broken down into a range of habitats and groups of species. And for each interaction in that table where there is a significant concern or it's worthy of consideration, we assess both the degree of concern to management, which is indicated by the size of the box, and the adequacy of the information, which is indicated by the colour of the box. Not surprisingly, if we look at those key risks to the reef that we identified in the Outlook report, fishing, climate change, coastal development, catchment runoff, these are the things that light up as being of high concern to management, and in many cases for which we need significantly more information than we already have. Equally, other more benign or better managed activities such as commercial marine tourism and scientific research have very little concern to management, and for the most part we think we have pretty good information for the ongoing management of those issues. Equally, we can look across the table at a particular group of species or habitat. I've chosen sharks and rays, and not only do we assess those against individual pressures, but in the far right-hand column we give an overall assessment for that particular component of biodiversity. There's something I'd like to stress at this point. I'm going to show you a couple more tables like this. These tables give the impression that everything is broken down into little boxes. Now, that's helpful for humans to break things down into bite-sized components, but we're under no delusions that this is actually how the system works. All of these various biodiversity components, I'm about to talk about ecosystem health, all of the threats are interacting with each other in an extremely complicated way, and it's those interactions that we really need to understand. So breaking things down into little boxes like this is useful, but gives a false impression and ignores that connectivity, so we need to bear that in mind. Equally, we can look at just a specific cell, and in this case I've chosen the interaction between coral reefs and climate change, and I'm going to talk about this in a little bit more detail in a couple of minutes, but each of these cells that has a coloured box in it, on the website, that box is actually a link to a separate web page of more detailed information on that interaction. So similarly, there's a table for components of ecosystem health. The columns in this table are exactly the same. The rows are the 4 components of the Outlook Report assessment of ecosystem health: physical processes, chemical processes, ecological processes, and outbreaks of disease and introduced species and pests. The columns, as I said, are exactly the same. Again, not surprisingly, climate change and catchment runoff give us very significant concern for their impacts on various components of ecosystem health, and are also areas where we really do need more scientific information. And I'd like to stress, one of the great things about the Outlook Report is that it represents a great step forward in the maturity of Gabrumpa's thinking about the system. We've got a long history of thinking about the biodiversity components on the reef, but we're now getting a much more effective consideration of ecosystem processes and ecosystem health, which I think is very important for adaptive management. I'd like to draw your attention to the fact that most of the ecological processes that we identify as being of importance in the reef are of significant concern to management. We also have one of these tables that considers the social, cultural and economic benefits from the Great Barrier Reef, and again the columns here are exactly the same: threats and pressures. On the left-hand side we have the various uses of the reef that deliver social, cultural and economic benefits. I'm going to be quite honest, this component of the framework is much less well developed than the others, and it needs a lot of work. So in relation to the whole system that I'm talking about, I encourage you to go to the Gabrumpa website and have a look, and we'd be very keen for your feedback on how to develop it further. One of the important comments I need to make is that although we assess some of those issues as having good information, that means we think we have enough information to be making sensible adaptive management decisions, that does not mean we don't need any more information. So I've picked a couple of examples where there are critical long-term monitoring programs. The top left is the population of nesting loggerhead turtles. The bottom right is the dugong population in the southern 2/3 of the marine park. We have quite good information on these issues. We know what we need to do, but we do need ongoing monitoring in order to be able to assess our existing management initiatives and determine their success and adaptively manage. So I spoke before about how every coloured cell in those tables was actually a link to a web page of more detailed information. This is what one of those web pages looks like for the interaction of climate change with coral reefs. The top of the page is just a reminder of what the coloured box said about the status of that issue. There's some summary extracts from the Outlook Report. There is a list of what we know about that particular issue in terms of the specific components of science that we have identified in the Outlook Online system. So remember, there are 600 pages in the Outlook Online, and this links those relevant pages to this issue. There are links to information about existing management policies and actions in order to deal with this particular issue, links to ongoing and future management actions so that scientists and others can see what are we trying to do about this issue now. And finally, if we have any defined research questions about that particular issue, they're listed there as well. Now, the point of this is to try and more clearly define the connections between the issues that face the reef, the science around those issues, and the management activities in order to help start that conversation between managers and scientists about science for adaptive management. Okay, I'm nearing the end. I want to spend just 1 or 2 minutes talking about something called Reef Permits. This is a new integrated online system. I apologise because this 2 minutes of my talk is very much for those of you who actually conduct research in the Great Barrier Reef Marine Park and need a research permit. This new system is really going to revolutionise the process by which you apply for permits, by which you track the permits that you have and get your permits and then actually do your reporting. We're going to hopefully launch this system by the end of this year, and when we do, we're going to come round to research institutions and universities and give seminars, training workshops and so on, so that people who need permits to operate in the marine park can learn how the system works. We are very hopeful that this will make the process of you applying for and managing your permits quicker, more efficient and easier for you as clients of the Gabrumpa. In particular, we are hoping that it will make it easier for you to do your online submissions, your returns against your permits. This is now going to become an annual process, but because it's online and you're able to upload data files, it will be much easier for you and more effective. So this is really just a heads up that this system is coming. Please feel free to come and talk to me about it if you would like. The expert on this at Gabrumpa is Melissa Cowlishaw, and I have some business cards of hers if you'd like to talk to her. But we will be coming to the various institutions and talking to you before we roll out the system. So in conclusion, I just want to reiterate the current outlook for the Great Barrier Reef under a business usual scenario is poor. However, now is the time for us to make decisions to do something about that, and we need targeted science to help future adaptive management. We've developed a new online information system to deliver our scientific information needs. It contains a lot of information, but if you are a scientist who is interested in working with us to improve the management of the marine park through your science, please come and talk to us about that. In particular, we need to bear in mind that holistic, connected nature of the system. We need science that will synthesize existing data to give us an insight into ecosystem functioning, impacts, thresholds, but particularly potential solutions to the problems that face the reef. The next Outlook report is due in 2014. The likely cut-off date for published science that we will use in that report will be December 2013. So again, if you are publishing and you know that Gabrumpa is not engaged with what you're doing, but you think your work is relevant, please come and talk to us. So I have one final thought, and my thanks to John Tanzer, from whom I have plagiarized this slide, and my apologies to those of you who've seen me say this before, but I think this is an important message. Reefs around the world are facing a very grim future, and the Great Barrier Reef is no exception to that. But we can make a difference, and in particular, if we have a strong partnership between reef scientists and reef managers, I believe we can deliver a much more optimistic future for the reef. And I'd just like to thank the many people in the audience who are already strongly engaged with the Gabrumpa in helping to make the Great Barrier Reef the amazing place that it is. Thank you.